Welcome. Today we're running a lightweight Vision Transformer MobileViT directly on a Raspberry Pi. First, we log in via remote desktop. To access the Raspberry Pi remotely, open a remote desktop client on your computer and enter the address mypi5.local. Use the username mypi and the password raspberry to log in. Once connected, you'll see the full Raspberry Pi desktop environment, allowing you to open terminals, launch Thonny or any other IDE, and work on your projects just as if you were physically at the Pi. This setup provides a convenient way to run Python scripts, install libraries, and manage files without needing a separate monitor or keyboard attached to the Pi. We open a terminal to start our setup. In the terminal, we first update the system and install virtual environment tools. Then we create a project folder called MobileViT_Pi and a Python virtual environment inside it. We activate the environment and upgrade pip for smooth installation of packages. Next, we install PyTorch for CPU-only Raspberry Pi and other required libraries like timm, Pillow, OpenCV, and Torch Vision. We quickly verify PyTorch and timm installation in the Python shell. If we see versions printed and MobileViT listed, we're good to go. Now, we start with the simplest code to check inference. To test our MobileViT script, we needed a set of sample images. We searched for freely available, publicly licensed images from sources like ImageNet and Wikimedia Commons. Once we selected 10 diverse images including animals, vehicles, and indoor scenes, we downloaded them directly to our Raspberry Pi using the get command in the terminal, saving them into a dedicated demo_images folder. This gave us a ready-to-use dataset to run batch inferences and evaluate the model's predictions efficiently. We open Thonny IDE and create test_MobileViT.py with the following content. Running this script,
we start by importing the necessary libraries: Torch for PyTorch, timm for the MobileViT model, pl for image handling, and Torch Vision.transforms for preprocessing. We then load the pre-trained MobileViT model using timm.create_model MobileViT_s and set it to evaluation mode with model.eval. Next, we open a sample image and apply a series of transforms, resizing it to 256 by 256 pixels, converting it to a tensor, and normalizing it with the standard ImageNet mean and standard deviation. Finally, we add a batch dimension using unsqueeze0 and run a forward pass with torch.no_grad to get the output tensor, which represents the model's raw predictions for all 1000 ImageNet classes.
Gives us the output shape, 1000, confirming the model runs. Next, we extend the code to print exact labels and measure inference time.
Before interpreting the model's output, it's essential to have the corresponding label file that maps the numeric class indices to human-readable class names. MobileViT outputs a tensor of probabilities across 1000 classes, but without the label file, these numbers are meaningless. To solve this, we download the ImageNet class labels file from the official PyTorch repository using erlib or wget, which provides a simple text list of class names in order. This allows us to decode the model's predictions and display meaningful labels like Labrador Retriever or Restaurant alongside their confidence scores.
We prepare some images from ImageNet/Unsplash for our demo, download them to demo_images folder and run our batch test script. At first, we noticed something odd. For some images, the model gave weird labels like dugong or iPod with 100% confidence. That's because we didn't use timm's official preprocessing. Transformers are extremely sensitive to input normalization and size. Here's the fix. We use timm's resolve_model_data_config and create_transform to get the exact preprocessing the model expects. Now, the outputs make sense. Dogs become Labrador or Samoyed, cats become Egyptian cat or Angora, and scenes are classified correctly. Here's a few sample results. Yellow Labrador looking_new.jpg top 1, Labrador Retriever, 73%. Push_van_cat.jpg top 1, Egyptian cat, 46%. Naxos_taverna.jpg top 1, Restaurant, 67%. Inference time 248 ms per image on CPU. Much better than initial garbage results.
That's it for running MobileViT on Raspberry Pi, fast, accurate, and ready for your projects. Don't forget to like, subscribe, and hit the bell to see more AI on Edge tutorials.